Hey guys, so I'm a verified educator on Unacademy, and along with that I'm also available on the Unacademy Plus platform where I'm taking live classes along with other educators. So in case you're interested in attending the live classes, you can subscribe to the Unacademy Plus platform using my referral code, that is SETHI, and that will give you 10% discount. Alright, and in case you're not interested in attending the live classes, you can watch the free courses that are available on the Unacademy. For that, all you need to do is go to the Unacademy website or download the Unacademy learning app and search my name over there, that is ACT. Once you do that, you will get the access to all the free courses that are available on the Unacademy platform. Alright, now let's begin with the video.
A very good morning to all of you. First of all, I would like to wish you all a very happy Independence Day, right? And on this occasion, I had this idea, or I didn't have this idea, like I had an idea of filming a video about this particular thing, which is called molecular music. Okay, it's an amazing and a very interesting idea which has heaps and bounds to go in the future, right? Now, what exactly is molecular music? When this concept came, it came around 1990s, like during that time. And the whole concept is that, see, if I talk about molecules also oscillate, right? They also vibrate, they also have a particular frequency of vibration, right? So when you are playing guitar or when you're playing any music, basically the sound that comes is due to the vibrations. Now over there, the frequency of vibrations comes to us in the audible region, because of which we can hear the instruments. But when it comes to molecules, they are vibrating so fast, the frequency is so fast that it is not, we can't hear the molecules, right? Because they are vibrating, they have a sound, they have an oscillation, but we can't hear about it, right? So what have scientists done is, they have tried to transpose the, let's say, the IR spectra of a particular molecule and try to bring it in the in a region where it is audible to us. Okay, that way we can actually hear the molecules vibrating, right? We cannot hear their actual vibrating sound, but we can transpose it to the audible region where we can actually try and predict how the molecule is sounding, right? Now, what are the advantages and why this concept is so unique and so inspiring? Because let's say I have IR spectra of a particular molecule, and all of you know that the IR spectra of all the molecules are different, especially the fingerprint region, right? So there are multiple peaks over there, right? So if I standardize this somehow, like the transposition from the vibrational region, the vibrational spectra into a spectra which comes in the audible region, if I can somehow transpose, like I can take a reference peak and then all the other peaks I can assign with respect to that particular peak, then what will happen is every molecule will have a different tune to it, right? Every molecule will have a different tune because the fingerprint region is exclusive to every molecule, right? And so you know, the pitch will depend on the intensity, okay, and then the frequency basically depends on the wave number. Like if the wave number is, let's say, 400 centimeter inverse, and then we have 900 centimeter inverse, so that might determine the frequency, and the intensity might be dependent on the pitch, right? So there are many parameters when it comes to sound, and those parameters which are there in the spectra, like the broadness, can be seen as amplitude, right? Like that you can transpose the IR spectra into the audible region. So every molecule will have a very unique sound, okay? So it is very very beneficial for, especially for scientists who are visually impaired, who want to, you know, determine what the structure of the molecule is. They can't see the spectra, okay? Secondly, there are certain parts which you miss out when you're looking at the IR spectra. So you can actually hear each and every sound, and for that particular sound you can identify which that molecule is, which is tremendous, okay? So you no longer have to, you know, you no longer have to measure the or you have to see the spectra and then, you know, have to remember, okay, at 1940 centimeter inverse this happens, at 1720 you get a ketone peak, right, a carbonyl peak. So you don't have to memorize that, you can go with the tune, okay? So it sounds very interesting, very inspiring, and especially if you present it to common people, they would really be intrigued by this kind of science, and maybe you can have the interest of youngsters getting into this field, because, you know, music is something which is universal, everybody correlates consciously or subconsciously, and it's really interesting because most of the great ideas have come from the subconscious mind. Like for example, your calculus structure of benzene, it came to him like a snake in a circle. A snake is trying to bite his tail. Then if you talk about the Watson-Crick model of DNA, again something that happened in their dream, in their subconscious. So there are a lot of such ideas, right, which take place in your subconscious. And so there are a few more which I am forgetting. Like there are 3 or 4 more such great discoveries that happened in the subconscious. Like they were accidentally discovered, or they actually came to them in the subconscious. Even for Sir Ramanujan, he said that the formulas for the mathematical formulas came to him in his mind, right, in his subconscious, like when he was sleeping or when he was dreaming about something, right. And it started to rain. So this is the whole concept of molecular music, right. It can be also applied to other places as well. So there is a scientist from England in University of Exeter, which is Dr. Long, and she is actually a musician and a scientist. So what she has done is, again, she has used this transposition to convert the 3D structure of proteins into sounds, into music, so that each amino acid has a particular note or a particular tune to it, right. And this was done earlier as well, when the different base pairs of DNA that are there, basically different base pairs of DNA, they were given a particular tune, or they were given a particular sound, like adenine, guanine, each was given a particular sound, and then the music was made with the you can say with the base pairs only, right. So once the base pairs are identified, let's say A, T, G, C, like that, they were repeating, right, they repeat in a particular pattern. So that particular music was given to it, like each base pair had a particular tone to it, and a music was made out of it. So that is quite fascinating, to be very honest, and it has leaps and bounds to go, right, especially for molecules which have a very complex spectra, like Raman spectra and IR spectra, which is very difficult to interpret. Maybe when you try to interpret it in the form of a music, it might be very simplistic, right. And since I am a big fan of Richard Feynman, I think this is a wonderful idea. So there it has leaps and bounds to go, molecular music. And not just in science, maybe in music also, there might be times in 20-30 years where people might be dancing in concerts where the molecules might be vibrating. So that's a fascinating idea. On the screen, instead of a DJ, there might be some molecules, they might show some molecules which are jumping around or vibrating around, and then there's music to it and people are dancing to it. That's crazy, right. So that is a crazy future, but I hope that happens, right, because science is something that really needs attention from people. It has been overlooked a lot, and it really needs attention from people. We need more and more people to join in and contribute their bits to science, right. So with this idea, I would end this video. I really hope you enjoyed the concept of molecular music. I'll try to give you some material down in the description box, so that you can read ahead and learn more about it, right, because I also learned it in the past few days only. So I can just give me my bit of what I understood. You can go ahead and read it and maybe understand it much better, right. So anyway, again, I'll wish you a very happy Independence Day. Thank you so much for watching this video, and if you haven't subscribed to the channel, do subscribe to the channel and also like the video, because I keep posting such interesting articles or videos related to science, research, internships, concepts, everything, right, employment as well, for those of you who are looking for jobs, right. So anyway, thank you so much for watching, and I'll see you in the next video.